don't like that because I think I failed you in some way because I meant to have this really sweet demo for you tonight, except that I had everything all set up, wrapped up, and locked from my home Wi-Fi network. So I failed, but so I'm going to have to improvise. Hey Google, hi. But you know how Google Assist works. You talk to her, she talks to you. But tonight, it's going to be about Android things. It's going to be about rolling your own Google Assistant instead of buying a Google Home or Google Home Mini. Mind you, it's cheaper because that's more expensive, but you get the options to do whatever you want that's not available commercially. So about using Android things. So we'll go through 4 steps: hardware, installations, development, and then lastly, connecting to Google Assist. Now, with Android things, connecting to Google Assist is not part of Android things, but just wrap up the whole stories, we'll do it anyway. So, Android things, what is Android things? Android things is a platform that is based on Android that you can use to target your OS and your apps into beyond tablets and phone into a device like Raspberry Pis. You probably heard of that. They're very common, and there's another alternative called NXP and some place called like a Pico Pi. So those are the only 2 supported hobbyist platforms that you can target. If you go to the website, Google will show a list of all the detailed specs, but I'm just going to highlight a few main things that sort of sway your purchasing decisions that affects your development and your use case. Storage on the Raspberry Pi 3B is SD card, so it's removable. You have to provide your own SD card. On the Pico Pi or the NXP, it's on board. It's not removable. You don't have to buy it, but it's on board. USB input, the Raspberry Pi 3B is micro USB and powered only. There's no data. Whereas the other NXP, USB 3 and data and power. So you can AED straight to it and talk to it. In terms of display, the Raspberry Pi 3B has HDMI and the NXP does not, but you can also build in your own touchscreen on it if you choose to do that. But that's just my effects how you and what use case you want to use. And lastly, slightly difference in the Wi-Fi spec, N and AC. It might affect you because the N is an older one on the Raspberry Pi, only 2.4 gigahertz, whereas the AC will give you up to 5 gigahertz. Magic about these 2 devices is that if you know about Raspberry Pi, they are about the size of a palm and they fit in about 5 volts, and it's almost the whole motherboard. So there's a chip, there's memory, there's USB slots, there's Ethernet, there's Wi-Fi, and there's audio jack. Amazing about it is that there is you can see this bar, there's this black bar on top, that's the GPIO. You can buy hardware plugins that adds on top like a Lego blocks with additional hardware plugins that you can add on it to enhance the functionalities, and with Android things you can control it, like maybe Android robots. Once you make those 2 choices, they are generally compatible in terms of the pin, because pin is exactly the same. I'll use compatibility with a bit of quote because you never know what goes on with hardware. So you buy one of these. Once again, the Raspberry platform has a lot of accessories that you can sort of stack on top, like that diagrams. You can go to a lot of websites. You can literally buy, I want this little piece that does Christmas tree lights. I want that little thing that does temperature measuring. You can just add it on, and you can control and detect that. So there's also this Android thing starter kit. If you went to Google I/O last year, you got it for free, or you paid for it with the entry fee. So it's basically the NXP kit with USB cable. Yay, they're expensive. Touchscreen. The rainbow hat, which is that little hat you put on top. It gives you a bit of a alphanumeric LCD display, some rainbow colors, LEDs, and 3 buttons, and a camera. Kind of almost like a tablet, but it's not a tablet. So this is one of the demo that I was going to show to you, but just get a picture. So you could basically build a Google Assist app, which is the demo I'm going to show you today, with the display screen on it, and it's almost like one of those Google Home product, what it's called, with the screens. Do you know? That's right, almost like that, except that you do it yourself. Voice kit is available. There are 2 models, the version 1 and the version 2. Now, I forgot to mention that the Android things only works on the Raspberry Pi 3B, not 2, not 0, not B+. So, which means the version 2 does not work. So, if you want to try one of these, buy the version 1 with the 3B. So, this one does not come with the Raspberry Pi. You could buy that yourself. It comes with a hat that gives you an amp, and it comes with a speaker for the amp, and come with a dual channel microphone, and a red button with LED lights. So that's the hardware. So you could stick to some of the standard kit or build your own, or even wire your own if you are into electronics. Oh, just to mention, if you buy one of this kit, the instruction comes with doing it using Linux and Python, not Android things. So in this talk, I'll show you how to do with Android things, which is not part of the instruction. So this is not an Android thing, it's just a Raspberry Pi Python thing. So to install Android things, you would go to an Android things website. There's a URL, but don't memorize that, just do a search. Android things, tools, installation setup, and you'll get to a page. You download it, it's very easy. Then there's a bit of a differences, depends on which hardware you use. If you use the Raspberry Pi, remember that Raspberry Pi has an SD card and no USB data transfer, so you need your laptop, Pixelbook, whatever, that's able to write to an SD card. Of course, once and the tool you download will give you that capability. Once you've done that, insert it to your Pi. Of course, it's not going to work without the SD card, and then you power it up. That's it. For the other options, connect the USB cable, and then the tool you download will download the image and write it to USB for you. So at the end of the day, you power up your devices. For the Raspberry Pi, I recommend you plug in your monitor and plug in your mouse because there is USB ports for it, so you can actually see that it's starting up and it's okay. But for the NXP, there is no such option, but unless you include a touchscreen as part of your hardware kit. So this is kind of what you see when you start it up if you have a screen. Android things and connect to network. So the next step is, unless you want to use Ethernet, set up your Wi-Fi, and that would basically complete your setup. So once you've got your Wi-Fi set up, so if you've got a screen, you can set your Wi-Fi. And for the Raspberry Pis, if you want to ADB to it, which you should, you will have to go through TCP/IP. Therefore, setting up the Wi-Fi is important, and you just do that, ADB connect android.local, because the device will actually publish itself as android.local, so you don't have to memorize and try and find out what the IP address is. And then, if you get that to work, ADB device should show up. If you are going through the other route, NXP, then it works with USB, so you just go straight to ADB devices, and just to confirm that ADB is working. So at the end there, you want it to be up, got connectivity, and ADB is working. And lastly, if you are on the Raspberry Pi and then you need to set up the Wi-Fi manually, you could do that through ADB once you get the ADB connection working. So at this point, you bought your hardware, you've installed it, jump straight to development. Android Studio. Start Android Studio, and there's one last option that it's always there, but you never noticed it. It's called Android Things. And if you click next, you get a setup project that's ready to run through ADB deployed to your hardware device. So everything's the same. You do Android manifest, you do activity, it's Gradle built, you have all the resources like Android, and you remote debug using Android Studio. So one of the hard part of doing IoT is that debugging, because there's a lot of platforms, various options, not many of them give you good tools for remote debugging. We talk about hardware that's stacked on top that you just bought and you can debug through it. So it's amazing tools. There are a few things that are unsupported. Don't try to memorize them. They're just things that doesn't make sense. But just be aware that things that are unsupported in it. But then there are things that are new to the platforms. It's the com.google.android.things. Make sense? There are things that are relating to all those plugins and attachments that's related to these Android things, Raspberry Pi's ecosystems. So one of the things is there's a black bar on top. It's called the GPIO. It's just lots of pins. Some of them are power, some of them ground, and most of the others are just input-output pins that will send current or not send current. So you can program that. So hopefully this won't get too technical, but just give an idea. So that the two models have exactly the same pin structures. You'll find the most important things are the voltage and the grounds, and they are identical. But they name some of the other pins differently. So if you happen to, say, use an instruction for Raspberry Pi, and they say, turn on pin this, and if you happen to use NXP hardware, you're just going to translate it in this hardware. So for example, the pin number 36 in Raspberry Pi is BCM16. In NXP, it's called GPIO2_IO07, just to confuse you. They just name it differently. But they're generally compatible if you look at all the pins map, and all the voltage and ground are the same. It's just everything else is just named differently. Knowing the pin name is important because when you start using the GPIO package, if you want to send current through or receive current through, you need the GPIO name. So Peripheral Manager is a standard Android things object. You get an instance, open the GPIO with a name, you set the direction. That's an in or out, so it's an input-output. So out means output. That means, for example, you want to set a light to go up, or you want to open a door. Something that out means something that the hardware understands. So if you wire your own things, you might might be switching on a current. And you set high means that it's true when you have current, and you set the value to true. That's it. Now you can control hardware using your Android code. Input is very similar. It's also pretty cool. The difference is you set direction in, and you can register a callback, so it acts like an event. So if I press a button, just like pressing a button on the screen, it's a callback. It's an event that you trigger, and you can act on it. So that pretty much explains how you can connect your Android code to a hardware. So all of these kits that you buy will have instructions to say, if you want this to happen, you're going to do this to this pin, and to the input or output, or a combination of them. So now you know how to download, set it up, connect to basic buttons and lights. Let's sort of make it connect to Google Assist. Maybe you press a button and can talk to it. So there is another SDK. Don't bother writing that down, just Google Assistant SDK and you can find it. It's an alpha too, so it's pretty new, I guess. Or they couldn't bother doing anything more about it. The documentation on it isn't great, other than they have like almost a Java doc kind of guide. Other than that, I find that to figure out how it works, this is the diagrams that I'm just going to explain. So it's a request and response kind of model. You send request, you get response back. And the SDK has all the objects model for you to fill it up and send across. They are also asynchronous, so it's unlike a REST API, you send something, you get something back. It uses gRPC, and when you send something, eventually you get a message back and it's a callback to you. So the sequence will go something like that. You send a request config, and the config object is kind of things like, all right, this is my language, this is my location, this is my device name, maybe here's my credentials, and maybe some options to say whether I want pure text or voice, that kind of configuration. And that starts a conversation you send across. And then if you want to do a voice-based conversation, like most cases you do, then you're going to start sending audio data in. Mind you, these are asynchronous, so you'll be sending them. And then at some point in future, you're going to start receiving callbacks in your SDK, and it's going to be the echo text. So do you recall when you start using Google Assist, when you start saying to it, you're going to see the words that comes out as you say. So that's the echo text that come back. So it's actually going on over the wire and come back. It feels almost instant. It's actually pretty quick. So at some point, it's going to give you a response with event type, end of utterance. Oh, I have kind of listened to what you said, and you have made a pause, or my special AI thinks that you have finished the sentence. It's going to say end of utterance, and I'm going to start replying the transcript, follow that as the response. So you get the full speech transcript, and then followed by a dialogue state up. You say, okay, this is the state of the dialogue. Are we going to end this conversation or not? And then a flow of data that comes through as audio that comes through as blocks of data. So that's the sequence of what happens when you use the SDK. All asynchronous. Now mind you, when you use one of these, talking devices, it's a synchronous operation. So you say something, you wait, and she says something back. You're not having a fight with her. But the API, it's asynchronous, so your code really has to deal with asynchronous on the network side and synchronous on the user side. So that's the kind of code complication you're going to worry about. Good example. So this one, if you want to capture what a user says and send it across, audio record, it's an Android thing, not an Android things. So it's API level 3, I think. So you basically create an audio record, and then there's a builder pattern that comes that's provided by Android. So you set, say, audio source, voice recognition, and you do a build, and you do a start recording, and at this point you can start reading the data. You can read a block of data. I think 2K is probably the default. And then once you read the block, you start sending to the Google Assist object. Doing a bit of a conversion gymnastics, byte string copy from audio data, and then you do build. That's you get your audio request, and you do that in loop until the end of utterance. So that's how you send audio data from one of these devices. Audio track is the reverse. Audio track is the one that plays back. So once again, audio track, it's a SD, it's an API that's from standard Android. You set transfer mode to stream, and that means when you start playing, you can then stream data as it comes through. So once again, you build a pattern, just like before, you build it, set to play, and the next part is when you get a callback, you get the data, and then you wrap it, once again, some wrapping gymnastics to an audio data, and then you write it out. You probably do it in a loop. One of the things that catches me, and I don't have a good solution, is when you start doing streaming, you get buffer underrun if your network isn't quick enough. So, for example, if you want to play a long music, so sometimes I'm finding that Google starts speaking and the network slowed for some reason. I don't have NBN, and it just kind of breaks the experience. So, don't have solutions for that. But that's kind of how it happens. It's just there's a lot more work around to get it working well. So that's the sums up of all the steps you have to do to build one of these your own hardware talking device. So when I bought one of these things, I've also added a camera. So technically, you can make it so that when I see a person, it starts talking. So start feeling more like an Android thing. Potentially, I'm also going to do put a stick on it and put a Roomba vacuum machine, so it's going to move. So it's going to be a cleaning, moving, seeing, hearing, and talking Android machine. I'll put a French mate outfit on it, and then I have an Android. Thank you.